for this lab, we'll be dissecting the angiosperm flower. Now, ideally, we'd want to use the hibiscus because the parts are much easier to see. So, longitudinal cut. Now, as you notice, the petals are a bit clumped together because I got it yesterday. And the key thing about the dissection is you want to cut lightly along, since we're doing a longitudinal cut, light longitudinal cut. So light cut and then separate, and then light cut and then separate. All right. So try not to do a heavy cut throughout. Now, so light cut all the way up. And so on the outside here, you have the anther filament, right? And up top you have the stigma running on the inside, style, and then down at the bottom you have the ovary, which we not seeing. Well, let me see if I can get the ovary better. I'm not seeing it, and petals are a bit squashed there. Sepal. Let me use this flower, which is in much better shape. And again, key with dissection, light cut and then separate. Right. So I'm going to use a light cut longitudinally. Try not to go too deep. Because a steady hand. Right. So here we're separating, and because this the flowers are much fresher than the hibiscus, it's not separating as easily. So don't get that separation. Do another light cut longitudinally. Now, problem separating. Cut along that longitudinal line because you really want it into two halves, right? Until there. Now, see, reason why we use the hibiscus. Now, in terms of the anther filament, even the can't quite clearly see the stigma and style in this. Down here is where the ovary would be, but here within the hibiscus, it's the stigma and style easy to differentiate, and the anther filament easy to differentiate as well. So ideally, we want to use the hibiscus for the dissection lab, and when doing the dissection, we want to use light cut along the region stated by the lab manual, so that we get to see all of the intended structures. Right. First, we dissect the flower, and within angiosperms, you have either dicots. The red bean is an example of a dicotyledon plant, and corn, example of a monocotyledon plant. Right. So we dissect first, dissecting the a dicot seed. Right. So for this part, and we want to cut longitudinally. See, and again, as with the flower, it's a light cut. Right. So we don't want to penetrate too far. Now, another key thing is that you want to ensure your blade is sharp. Now, and if it is, in this instance, I'm trying to penetrate and the blade isn't penetrating easily, do have another blade here that I'll try. So if your blade is not penetrating easily, that's an indicator that it's not sharp. and we want a sharp blade so that we don't cut too far for each cut, right? So you want a very controlled cut for the dissection lab, whether it's corn. And for those of you later on, you may be dissecting animals. Again, you want a sharp blade and a controlled cut. And the other thing that could change with a dissection lab is, say for example, if you have harder tissue, then you'd need a larger blade. Which is why butchers have various knives for in terms of various things they want to cut. And so these are structures here, right? And so on this side, right, epicuttle, hypocuttle, radical at the bottom there. Right. And here are two cotyledons on your red bean seed. Your endosperm is in there, and that's where the seed would basically get its food from on the inside, in order for germination to occur, right? And so light controlled cuts with a sharp blade, because the key thing about the dissection, you don't want to destroy the structures because you want to be able to identify them. Alright, so the second seed we're going to dissect is the corn, again longitudinally along the side. Just remove a bit of excess corn there. And so for the red bean, the key thing is to let it soak for a bit so that it's easier to cut, because the red beans are usually hard. The corn, however, usually fresh from the cob, right? You don't want it dried out because it's harder to dissect. But the other thing, you don't need to soak the corn. That's a difference. So again, sharp blade and a controlled cut longitudinally, right? Sharp. And so your corn, notice the difference between your corn and your red bean, right? So for a red bean, the embryo was along here, right? So a bit of it got cut. The embryo is along here, epicuttle, hypocuttle, radical. And the embryo in this one, let's look, it seems to be on this side. The embryo is here, and the endosperm is here, right? For both these labs, however, once you do the dissection, it's much easier. You won't have a watch glass because you're at home, but when you do the dissection, the structures are much easier to identify using a watch glass, using a magnifying glass, sorry. Right, so it's the embryo here and the sperm here, right?